Hi, future doctors. Welcome to the next class. In this class, we'll discuss LCR series circuit. So, in this, all inductor, capacitor, resistors. So, they will connect like this to AC source. So, V is equal to V naught sin omega t LCR. Otherwise, they may do like this also. Both are going to be same. So LCR. How these three connected means? So V is equal to V naught sin omega. So these three connected in series. Now voltage across inductor, that is going to be VN. Voltage across capacitor, VC. Voltage across resistor, VR. So whenever these three in series, what will be same? Current is going to be same. Now see one by one, what is VL? I into resistance of this L, that is going to be XL. What is VC? I into resistance of capacitor, that is XC. What is VR? I into R. Correct? If you want, what is the RMS voltage across inductor? You have to apply here IRMS. Correct? Next, this is voltage across inductor, capacitor, resistor. Now, what is the effective voltage? So, what is the effective voltage? How we will get means by using phasor diagram. So, in phasor diagram, in which direction we are going to take? For convenience, we are drawing very easily. So, voltage across resistor VR. So, voltage in resistor, current in that resistor, both will be in same phase. Therefore, current also we will draw in this direction. Once we have current drawn, this will not be changed. But always current should be drawn in which direction? Along voltage across resistor direction. Why? Because both are going to be in same phase. In pure resistor we discussed. Next, where we have to take VL and Y. Where we have to take VL means voltage across inductor, because current lags voltage across inductor by pi by 2, 90 degrees. Next, where we should take VC? VC is going to be here. Why? Because current leads voltage in capacitor by pi by 2. Now, three voltages we have drawn, isn't it? So VL, VR, VC. Now they will ask question, how they will ask means what is the phase difference across inductor and capacitor voltage between VL and VC? What is the phase difference? 180 degrees. That is going to be 5. Very important one. Next, now what is the effective voltage? How we are going to calculate? Now any two we can do very easily. VL and VC both are opposite. Therefore, resultant you will get this one, VL minus VC. No sir, I will take VC minus VL, that is also fine. VC minus VL also you can take. At the time this arrow mark will be coming downwards, that one also I will draw later. So presently we will see this. Now this is VL minus VC, this is VR. Now what is the effective voltage means? This is the effective voltage, VE, that is only VLCR. So, in our textbook, after pure capacitor, resistor, inductor circuit, you will be having directly LCR. Therefore, they will write simply V across LCR. How you will get this VLCR means? Here two things you got. One is this is VL minus VC. Another one is horizontal one. This is going to be VR. Therefore, what is the effective voltage we are going to get means VE or VLCR is going to be equal to root of VR square. VR square plus what is the voltage across in this direction? VL minus VC whole square. That is nothing but effective voltage across LCR series circuit. Now what is VR? We have written here IR. Therefore, IR whole square plus IXL minus IXC whole square. So if you wrote I square common, if you wrote outside of the root, I into root of R square plus XL minus XC whole square. This is the effective voltage across LCR. Now, effective voltage across LCR is equal to I into, always we will get here which term? I into resistance, I into resistance, I into resistance. Therefore, here also I into resistance. That resistance only we are calling it as Z. That is called impedance. I told you only one is there means reactance. More than one is there means impedance. So Z LCR or Z we will call impedance of the circuit. What is impedance? Impedance means resistance offered by LCR components to the flow of alternating current. This is the effective voltage across LCR. Now, what is impedance? Z is equal to root of R square plus XL minus XC whole square. Now, same circuit if you have drawn, this is VR, this is I, VL, VC. VC minus VL if you have drawn, let us assume. VC minus VL. Then what you will get effective? You will get like this, effective voltage. But here in place of XL minus XC, you will get XC minus XL. But both are going to be same. Why? Because square is there. Square is there for XL minus XC. Next up, this angle phi. So, current and effective voltage is how much angle, phase difference means phi. So, what is this phi and how much current is passing through this LCR circuit? Always will not write I is equal to I naught sin omega t. So, in case of resistor we wrote same omega t. In case of inductor we wrote minus pi by 2 because current lags pi by 2 in inductor. In case of capacitor we wrote plus pi by 2. In LR circuit, in LR minus pi we wrote, in CR plus pi we wrote. Here we can't say, therefore we will say plus or minus pi. So which is leading, which is lagging, or which is dominating in this? If you don't know, presently we will write I naught sin omega t plus or minus phi. Now what is I naught here? Where I naught is V naught by which term you are going to get here? Resistance, that is nothing but impedance visible. So I naught is going to be V naught by Z. In pure resistor circuit, V naught by R. In pure capacitor circuit, V naught by XC. In pure inductor circuit, V naught by XL. Isn't it? All we will write once again. So this is nothing but what is the phase? How we will get this phase? How we will get this phase means tan phi is equal to opposite side by adjacent side. So for this, if it is going to be phi, opposite side is going to be VL minus VC. Adjacent side is going to be VR. Therefore, from the diagram, we will write tan phi equal to VL minus VC by VR. That is going to be IXL minus IXC by IR. That is going to be tan phi is equal to XL minus XC by. So this is nothing but phase angle, effective voltage and the impedance of this circuit, LCR circuit, how we are going to do. Now see here, depending on this phi, when capacitor is dominating, inductor is dominating, and when this circuit, LCR circuit will be acting as pure resistive circuit, we will see. So if XL is equal to XC, XL equal to XC means inductive reactance equal to capacitor reactance, means both the resistance of capacitor and inductor are going to be equal. Then how impedance is going to be acting? Z is equal to what is our formula? Root of R square plus XL minus XC whole square. Correct? So if both are equal, XL, XC, then what you will get? Z is going to be R. Whenever Z is going to be, impedance is going to be resistance, then this current I naught is going to be V naught by R. Whenever I naught is going to be V naught by R, this is in which circuit you are going to get this? This will be getting like pure resistor circuit. In pure resistor circuit, what is the current? I is equal to I naught sine omega t, because there is no phase difference. Phi is going to be 0. Whenever XL equal to XC, you can multiply with I. IXL equal to IXC. Then what are going to be equal? IXL means what we wrote here? VL equal to VC. Then this current we will say maximum. Current is going to be maximum and impedance is going to be minimum, we will say. This is the condition for minimum impedance and maximum current. Whenever resistance is small, what will happen? Current is going to increase. Next, whenever XL equal to XC, we will write XL as XL as omega L, omega naught. XC as 1 by omega naught C. So omega naught square equal to 1 by LC. Then what is omega naught means? 1 by root LC. This is called resonant angular frequency. If omega naught can be written as 2 pi f naught, then f naught is 1 by 2 pi root LC. So 1 by 2 pi root LC is nothing but resonant frequency. Resonant frequency or resonance frequency. This is resonant angular frequency. Omega naught, if you write, you will use angular frequency. Resonant or resonance is going to be same. Okay. So at resonance frequency, again, impedance is minimum, current is going to be maximum. When resonance occurs means if XL equal to XC directly we are giving. So this is the formula for resonant frequency. And this is the equation for maximum current, and this is the equation how current is going to be changing at this condition. See how many you are going to get because of this one thing. Next, second one in this. If XL is greater than XC, which is more? XL is greater than XC. Then in this circuit, which is going to be dominating, how we are going to get. So we will see. So, but before going to this, here we left one point. What about phase? Tan phi equal to, what is the formula? XL minus XC by R. Otherwise, VL minus VC by VR. So at this condition, if XL equal to XC, at a resonance condition also they will say. So XL equal to XC means this one is going to become 0. Phi is going to be 0. In pure resistor, there is no phase difference between current and voltage. Therefore, if voltage, AC source of AC, V naught sin omega t, current also I naught sin omega t. Isn't it? LCR circuit will be acting as pure resistor circuit at XL equal to XC and phase is 0. Next up, in this condition, because we are going to get with tan phi, then this one. From this also you can get, but this will be easy for us. So XL minus XC by R, this is going to become positive. So XL is greater than XC means tan phi is positive. So L is more. XL is more means this is called L dominates. So L dominate means this circuit will be acting as L dominating circuit. L dominating circuit means in case of inductor, current leads or lags. Current is going to be lagging. Therefore, this formula we can write it as current formula I naught sin omega t minus phi. What is that phi value? In this, if you substitute, we are going to get. They will give XL value, XC value, XL minus XC by R. If you do, you will get tan phi. From that, you will get that phi. That phi you have to substitute here. This is nothing but L dominating circuit. If L is dominating in inductor, current is going to be lagging. How much angle it is lagging means phi. That phi we will calculate by using this formula. Next, third one. Third one, I think you may understood. XC is greater than XL. Now, which is more? XC is more. Therefore, that is called capacitor dominating circuit. If capacitor is dominating, current leads. How much it is going to be? I naught sin omega t plus phi. Again, how you will calculate phi means by using this formula. Then at the time, tan phi is going to become negative because XL minus XC, XC is more. Tan phi is negative means so current is going to be lag, isn't it? So this is about LCR circuit whenever it is acting as L dominating, C dominating, and which is equal to pure resistor circuit, and how to get phase angles and which is leading, which is lagging, resonant frequency, condition for resonant frequency or condition for minimum resistance, condition for maximum current. All these are going to be formulas. Again, we will continue this LCR in our next class. So till then, you can see once, you can revise. Thank you.